Greetings to every one of you. So in this video we are going to discuss another very important concept from machine learning, that is temporal difference learning, TDL. It is used in reinforcement learning for predicting the cumulative future rewards. It is a model-free reinforcement learning method which learned by bootstrapping from the current estimate of the value function. It takes the advantages of two methods, that is, one is Monte Carlo and another is the dynamic programming. Like Monte Carlo, it takes the sample from the environment and perform the updates based on the current estimates, like the dynamic programming. So in the dynamic programming, the estimates will be that is calculated step by step. It can be that is used in non-episodic task. This technique uses the difference between successive estimates to improve the predictions. The TDL can be defined by the formula V of S dash t replaced by V of st plus alpha into R t plus 1 plus gamma V of st plus 1 minus V of st. So here this V of S dash t, it is a new value of the state at time t, and this S of st is the former estimation of value of the state S at time t, and this alpha, it is a learning rate. Similarly, the R t plus 1, it is a reward value at time t plus 1, and gamma is the discount value for the next state or the future value. This V of st plus 1, it is the current state, minus V of st is the former estimation state S at time t. So using this formula, the TDL works. So since the Monte Carlo, it is another learning method, we are using some concept of Monte Carlo in the TDL. So that let us also discuss this Monte Carlo learning. The Monte Carlo methods are wide type of computational algorithms that uses random sampling to obtain the results, like the probabilities or the expected values. It does not have any predefined model. Monte Carlo, it works on episode by episode and return the value only after the completion of any particular episode. It works on experience sampling, so it means that the sequence of state, action, reward from actual or simulated environment is working can be defined with the help of this formula V of S dash t replaced by V of st plus alpha of gt minus V of st. So here V of S dash t, it is a new value of state S at time t, and V of st is the former estimation of value of the state S at time t. This alpha is the learning rate, and this g of t, the return value at time t step t, time step t, minus V of st is the former estimation value of state S at time t. The expected return value starts here in this state. So with this the formula we can define this Monte Carlo method. The next topic is advantages of TDL. Already I explained that it does not require a model of the environment. The TDL can learn before knowing the final outcome. So every time it estimates the value step by step because of the dynamic programming. With the help of the dynamic programming, it is able to calculate the values step by step. It incorporates the features of Monte Carlo and dynamic programming. Less amount of memory is sufficient as far the TDL concern. It can learn without the completion of the episode. Note regarding the policy, the terms we use to represent the policy in TDL, that is V pi of S, it represents the value at the state S under the policy, that is pi. Q pi of S comma A, this represents the action value A at particular state S under the policy pi. Now let us discuss the on policy and off policy learning. The actions which give high rewards are chosen as the policy. Hence basically what is required is the policies should not be very strict. There are three types of policies available. Number one, it is greedy. Number two, epsilon soft. The third one is soft max. The first method, greedy, in which the action with the highest reward, that is selected. So it is the greediest action. So which action will give the maximum reward, that particular action will be that is selected by the system. So that is called greedy. Then E soft. So this is like greedy, but the best action is selected. The probability, that is 1 minus epsilon, and a random action is selected at the rest of the time. Number 3, soft max. So this method assigns different ranks and weights for each and every action. So based on the ranks, the given ranks and weights, the best action is selected. These are the three methods that is available for the policies. We have off policy. Off policy methods can update the estimated value functions using hypothetical actions. So those which have not actually been tried. Similarly, off policy algorithms can have separate exploration from control, so that agent can learn the tactics of learning. So as a result, instead of learning, the agent will learn how to learn. So far we have discussed about what is TDL, that is temporal difference learning, and Monte Carlo learning, and also we discussed about what are the different advantages of this TDL, and also we discussed about the on policy and off policy learning. I hope you understood the concept. Thank you. Keep watching.